So we did these on Friday because I think this is about where we left off. As we walked through how to solve these by hand, and we also saw that the TI-30XS, not the graphing calculators, will do these for us. So we could actually plug these in and get the answer. And I believe I said 25 through 30 are not on the test. So the next one we're going to be looking at is these function operations. F plus g of x, f minus g of x, f times g of x, and f divided by g of x. So we'll look at number 32. And the first one we're going to have is our f plus g of x, which is really just saying that we're taking f of x plus g of x. We're adding these two functions together. Now our f of x function in this case is 4x to the 5/4. And our g of x in this case is 2 times x to the 1/2. Now is x to the 5/4 the same as x to the 1/2? Are they the exact same? Well, no. So that means we can't actually add them together, because x to the 5/4 is saying that we have x times, let me write, 4th root of x. X to the 1/2 is the square root of x. Well, x times the 4th root of x is not the same thing as the square root of x. So what that tells us is that, well, we can't actually add these together, so that is our answer. So if we have a setup like this here where the exponents are different for the variable, well, we can't add them. The only way we could have added these together is if we had x to the 5/4 and x to the 5/4, or both of them were x to the 1/2. We have to have them as the exact same exponent. Otherwise, we can't add or subtract. Any other questions on f plus g of x?
Is 1/2 not equal to 2/4?
1/2 is equal to 2/4, but we would need to be 5/4 and 5/4. Because we could have had x times the 4th root of x and rewrote 1/2 x as the 4th root of x squared, but again, they're not the exact same. Because when we add variables, we have to have them be the same. An easier way to look at this would be, because this is saying x cubed plus x squared. Can we add these here? Well, no, one of them's a cubic, the other is square. Because unless the variables are the exact same, we can't actually combine them. Does that kind of make sense? Another way to look at this is if we said x was 2 to the 5/4, and 2 to the 1/2. Neither one of these is going to give us a nice number, but 2 to the 5/4 would be 2.3784. 2 to the 0.5 is 1.4142. They give us totally different values. Because if the exponents were the same, then we can actually add or subtract. Does that kind of make more sense? Essentially, I'm saying I have 4 of this and 2 of this other one. They're different. The only way we can add or subtract with variables is if these variables are the exact same. Because 5/4 and 1/2 would not be the same, so we can't actually combine them. Does that kind of answer the question? Yeah. Unfortunately, with these here, because the variables have a different exponent, we can't combine them with addition and subtraction. Any other questions on any of this here? So if we look at subtraction, it's going to be very similar to the addition, because we're going to have 4x to the 5/4 minus 2x to the 1/2. And again, just like with addition, we can't actually combine these terms, because we don't have any like terms between x to the 5/4 and x to the 1/2. So that is addition, subtraction. We just end up writing it out. We don't have to do anything with it. Now the next one that we have is multiplication, f times g of x, which would be f of x times g of x. Now unlike with addition and subtraction, we can actually simplify this one. Now when we replace it, we'll have 4x to the 5/4 times 2x to the 1/2. Now the first thing we can do is multiply our numbers, 4 and 2. 4 times 2 is 8. Now when we multiply like bases, x and x, we add the exponents. So we'd have 5/4 plus 1/2. Now at this point here, we could type it into the calculator, not the whole thing, just the 5/4 plus 1/2 to simplify that down. And 5/4 plus 1/2 works out to be 7/4. And that's all we have to do for multiplication. Any questions on addition, subtraction, or multiplication? That brings us to the last one, which is division, which would be our f divided by g of x, which is the same as f of x over g of x. Now our f of x function is 4x to the 5/4. G of x is 2x to the 1/2. Now at this point here we can divide. 4 divided by 2 is 2. Now when we divide like bases, x and x, we subtract their exponents. So we'd say 5/4 minus 1/2. And again, just like with addition, 5/4 plus 1/2, 5/4 minus 1/2, we can plug into the calculator, and it would give us 3/4. So these here would be our 4 answers. Any other questions on this here for number 32? So we're good with problem number 32, yes? Now 33 and 34 we're not going to worry about because I'm not going to be asking y'all about doing these f plus g of x, f minus g of x, f times g of x, f divided by g of x, evaluating for a number. We're not going to have you do this here. So we don't have to worry about these two here. But we are going to look at 35 through 41, composite functions. Is there one of these composite functions that y'all want to look at? Bless you. Now we can go on and just look at 35. And with any of the composite functions, we're going to work from the inside out. So when we look at this first problem here, the most inside that we can get is g of x. And for us here, g of x is what? Negative 2x plus 5. So we're going to go on and replace g of x with its function, negative 2x plus 5. Now after we do this here, we're going to take that and plug it into f of x, because f of x is 7x minus 2. Well, here we've replaced x with negative 2x plus 5. So everywhere there's an x in the function f of x, our 7 times x minus 2, we're going to replace that x with negative 2x plus 5. So what that'll give us is 7 times negative 2x plus 5, because we replaced the x with our negative 2x plus 5. And then we'll have minus 2. Any questions on this so far? Now we just need to simplify, so we'll distribute the 7. 7 times negative 2x is negative 14x, plus 7 times 5 is minus 2. Well, 35 minus 2 is going to be plus 33. So f of g of x is going to be negative 14x plus 33. And that's it. Is there another one of these that we want to look at? 36, 37, or 38? 38. G of x. Now, just like with the one we did before, we're going to start inside out. So we'll start with g of x. Now, g of x in our case is negative 2x plus 5, I believe. So we're going to place g of x with its function, negative 2x plus 5. Now, just like with the previous one, because on the previous one we plugged in the negative 2x plus 5 into f of x. But this time we're plugging the negative 2x plus 5 into g of x. So that would give us negative 2 times our negative 2x plus 5 plus 5. We replace the x in g of x with our negative 2x plus 5. And now at this point here we would simplify, so we would distribute the negative 2. Negative 2 times negative 2x is 4x. Negative 2 times positive 5 is going to be negative 10 plus 5. Which, if we combine like terms, negative 10 plus 5 is, so we get the function 4x minus 5. And with all these composite functions, we just want to work from the inside out, taking it one step at a time. Any other questions on 35, 36, 37, or 38? We good with these here? Yes? Yes. So you want to look at 39? So 39. So we're going to start from the inside out. So the farthest inside we have is f of 4, yes? So we're going to plug 4 into f of x. And if we do that, we would have 7 times 4 minus 2. We can do 7 times 4 minus 2 in the calculator, yes? Well, yeah. I mean, we could do it by hand. Say 7 times 4 is 28. Minus 2 is 26. So simplifying that gives us a g of 26, which means we're going to plug 26 into g of x. And if we plug 26 into g of x, we would get negative 2 times 26 plus 5. Well, again, I can do negative 2 times 26 plus 5 in the calculator, yes? So at this point, again, we can type it in. Or we can do it by hand, because negative 2 times 26 should be negative 52, plus 5, I believe, should give us negative. And that's it. That's all we have to do for this. Any other questions on 39, 40, or 41? Well, the only difference between 39 and 40 compared to 41 is that we have to do this inputting it back into the function 3 more times. It's not any different. We just repeat the process an additional 3 times to get the answer to 41. So are we good with these here? If there aren't any other questions for 35 through 41, we'll move on. Inverses, finding the inverse will not be on the test. I'm not going to do inverses on the test, because a majority of the test is going to be solving. There will be a few you will have to check your answers because at least one solution will not work. And again, it will be in all caps. I believe, if I remember correctly, I wrote it in the instructions, check your answers in all caps. And I am assigning a point or two to checking your answer. So if you plug it back in and check it, you get those points. If you don't check it, you lose those points. Okay? So looking at 44 and 45, is there a question on 44, 45, or one of these that we want to look at? We can do 45. Now, whenever we solve these here, the first thing we want to do is to get the radical by itself, no matter what the power is. So here we have the square root of y minus 4 plus 7 equals 15. So is the radical by itself? Well, no, because of the plus 7. So the first thing we can do is subtract 7 from both sides, which will tell us that the square root of y minus 4 is equal to 8. Now is the radical by itself? Yes, because we don't have anything being multiplied in front of the radical or added or subtracted to it. We don't really care about the minus 4 at this point. So at this point here, we're going to put both sides to the second power because, again, we want the radical to simplify out. Does the square root of y minus 4 squared? Well, the square root and square will cancel, telling us that y minus 4 is equal to 8 squared is 64. And last but not least, we just need to solve for y. So we would add 4 to both sides, telling us y is equal to 68. And again, if it says in the instructions to check your answer, well, for this here, we would just say that the square root of 68 minus 4 plus 7 is equal to 15. That's part of it. Well, we can type that whole thing into the calculator. And if we type this in, 68 minus 4 is 64. Square root of 64 is 8. And 8 plus 7 is 15. 15 is equal to 15. Okay, I've checked it. Because I could have typed that all in and it would have told me that it's 15. Okay, I've checked it and we're good to go. Any other questions on this here? Now, if you want to work it out step by step, saying that writing that the square root of 68 minus 4 is 64, so having the square root of 64 plus 7 equals 15, simplifying to 8 plus 7 is 15, 15 equals 15, that works as well. Any other questions on 44 or 45? Questions on 46 or 47? So the first thing we need to do is to get the radical by itself. Is it by itself? Yes. Okay, so we're going to put both sides to the nth power. So what are we putting both sides to? Third, because it's a cubed root. Because the cubed root cubed simplifies out, telling me that I have 2x minus 1 is equal to 8. Now that we have all the radicals gone, we can just solve for the variable. So the first thing we can do is add 1 to both sides, which will tell us that 2x is equal to 9. And last but not least, we would divide by 2, telling us x is equal to 9 halves. I just leave it as 9 halves. I will, but it's sometimes better to just leave it as a fraction. Especially as this here, I mean, it would be 4.5 or 4.5 are the same thing, but We can leave it as 9/2. That would work just as fine. Any other questions on these here? So what would we need to do first to get the radical by itself? So we subtract 27 first, which will tell us that 3 times the square root of 2x plus 7 equals, and what do you think we do next? Divide by 3, or I'm just going to apparently erase part of it. Now the 3 and 3 would simplify to 1, telling us that the square root of 2x plus 7 is equal to negative 23 over 3. Now what would we do next? So we would square both sides and solve. So we would square both sides. Well, these would cancel, telling us that 2x plus 7 is equal to 9. So 9, 6, 6, 529. And then at this point here, we would subtract 7 from both sides, which is still going to be a pretty big number. Because 9 times 7 is 60. 466 over 9. And then we would divide by 2. 233 over 9 would be our answer. Now, if we plugged it back in, we would actually get a no solution. But did the overall steps make sense? Now, realistically, we could have stopped before we squared it. Because if we have an even root, what numbers can we not get out of it? They can't be negative. Because we can't take the square root of a number and get a negative answer. So the fact that at this step here, that the square root of 2x plus 7 equals negative 23 over 3 is an automatic giveaway that this doesn't work. That this is not going to give us an answer that works. Because if we plugged it back in, we wouldn't actually get 4, we would get 31, most likely. This won't work in the original problem. So it doesn't work out for us here. Now, there's not going to be one where all the solutions don't work. There's going to be a few where one of them doesn't. We do need to check those. And again, it's going to be in bold. Check your solutions where those are going to show up. But I'm not going to put one in there where we end up getting a complete no solution, where none of the solutions work. One of them will work. And I don't know why I keep scrolling. But any other questions on 46 or 47? Questions on 48 or 49? Now, when we worked through most of these here, the first thing we said was to get the radical by itself. Then we kind of added a subclause, or kind of an extra note that if there's more than one radical, we need to even them out. So what can we do to even these out? Add the 9th root of 4x, yes? And if we add it, well, this is how I would do this one, because we're going to add it to both sides. Now, the 9th root of 4x is going to become positive, yes? And that's essentially what it's going to look like. That's how I would do it. But if we work this out, we can add the 9th root of 4x to both sides. And if we do that, well, these here become 0, telling us that the 9th root of 2x minus 1 is equal to the 9th root of 4x. I mean, doing it the way I showed you just a second ago is just a faster way to do that, because we know that the 9th root of 4x is going to become positive, and they're both going to be equal to each other, so instead of rewriting it out, I kind of just edit the original function, or the original equation. Okay, so we have the radicals as by themselves as we can possibly get them. So we need to put both sides to what? The 9th power. Well, 9th root and 9th power simplified, telling us that we have 2x minus 1. Here, the 9th root and 9th power simplify, telling us that we have 4x. Now we just need to solve for the value of x. So we can subtract 2x from both sides. Which will tell us that negative 1 is equal to, and last but not least, we would divide by 2, telling us x is equal to negative 1/2. And this one works, because we can take the odd root of a negative number. That's fine. We can take the odd root of a negative number, and it will give us a negative. But we can't take the even root of a negative and get a negative. It just doesn't work. We can't take the even root of a negative number. Because anytime we take an even root, it's got to come out positive for these here. And this here is different than if we applied an even root to it, because then we're looking at more a squared equals 16 here. A can be positive 4 or negative 4 because we're squaring it. However, the square root of a cannot equal plus or minus 4. We can't go the other way around. If we're looking at the square root of a equals 4, a is not going to be positive or negative 16. Because the only number that this can be is 16, because the square root of 16 is 4. The square root of negative 16 is not 4, it's 4i. Because these here are different equations. Any other questions on 48 or 49? We're good with 48 and 49? Questions on 50 or 51? 50. This one here is going to be one of the ones that shows up in the check your answers. Check your answers. One big giveaway that we're going to need to check our answers is if a variable is outside the radical. If we have a variable outside the radical, we're going to need to check our answers. Now looking at this here, is the radical by itself? Yes. So here we can go on and square both sides. Nice enough is that here the square root and square cancel, telling us that we have 3 minus s is equal to, well, here we have s minus 1 times s minus 1. Now we need to use the distributive property to factor this out. Well, what is s minus 1 times s minus 1 going to become? It would be s squared minus 2s plus 1. If you see how that works all the way out, that's fine. But we could also say s times negative 1 is negative s. Negative 1 times s is negative s, and negative 1 times negative 1 is plus 1, which tells us that we have s squared minus 2s plus 1. If we see how those actually combine and we can do that all in one step, that's fine. But if you need to still write it out, that's fine too. There's nothing wrong with writing it out. Any questions on how we got to this point here? I might be nice and just say that s minus 1 squared is s squared minus 2s plus 1. I might write it in the problem. Now what do we need to do next? We need to get this thing equal to 0. So we can subtract 3 from both sides. Well, if we want to, we can also add s. If we want to do it in one step, we can do it in one step. If we want to do it in 2 steps, we can do that as well. Now this would give us 0 is equal to s squared minus s minus 2. Any questions on how we got to this point here? Now at this point we can try graphing this, but in the graphing calculator we wouldn't put s, we would put x. We can just replace it with x, it's just a variable, and see where it crossed the x-axis. Because any point that it crosses the x-axis would be a solution that makes this function equal 0. Now the other way we can do this is factor. And most likely we're not going to get fractional answers because the variable in front of s squared is, or the number in front of s squared is 1. So the likelihood of us getting rational answers is low. Actually, it's 0. Well, let me take that back. We will get rational answers, but they won't come in the form of fractions because whole numbers are still rational. The only way that we'll get decimal answers from this is if the answers worked out to be irrational. Then we couldn't factor or graph it. But looking at this here, since the 2 is negative, we know our signs would be opposite. The only factors of s squared are s and s. And the only factors of 2 are 1 and 2. Which one would be negative? It would be the 2, because we need the middle term when we multiply to be negative, so the bigger number has to be negative. And we could check it s times negative 2 is negative 2s. 1 times s is going to be plus s, which gives us a negative s, which is the middle term that we wanted. Yes? This here? Since s squared, since we have a term, a variable with a degree greater than 1, we've got to get it equal to 0. Because the two ways that we can solve this at this point is either factoring, because any two things multiplied together to equal 0, one of them has to be 0, or if we graph it, we need it equal to 0. So this here, I went on and did both steps at the same time. Because normally we would add s to both sides, rewrite it, and then subtract 3 and rewrite it. But instead of doing that, I just went on and did it in a single step. Does that kind of make sense? I think that's probably where a little weird. Yeah. Yes. Okay. And the last thing we need to do is set these equal to 0 and solve. So we're saying that s plus 1 is equal to 0, or that s minus 2 is equal to 0. So with s plus 1, we would subtract 1, saying s is equal to negative 1. Over here, we would add 2, saying s is equal to 2. Any other questions on how we got negative 1 and 2? Now again, we need to check this. So we can plug negative 1 in first. So 3 minus negative 1 is equal to negative 1 minus 1. Now again, we could type this each side individually into the calculator as a whole. So we could type in the square root of 3 minus negative 1, hit enter, and it's going to tell us that it's 2. Because 3 minus negative 1 is 4, square root of 4 is 2. On the other side, we have negative 1 minus 1 is negative 2. And is 2 equal to negative 2? No. So that means s equals negative 1 does not work. And again, on the test at this point, we would know that s equals 2 does, because I'm not going to throw two solutions that don't work. But again, on the test, you'll still need to check it. 3 minus 2 is equal to 2 minus 1. Now again, you could plug into the calculator square root of 3 minus 2, hit enter, and it'll tell us that it is 1. And 2 minus 1 is 1. So that does work. If we work this out by hand, well, 3 minus 2 is 1. If we take the square root of 1, we get 1. And 1 is equal to 1. So s equals 2 works. So on this part of the test, you will need this check step, because that is worth points. I am giving you points for checking your answers. So on the test, and I'll double check and make sure none of them, especially on the check, where both are going to fail. All of them will have at least one answer. There could be some that have 2 that work, but we'll have at least 1. So if both of these failed, if for some reason you plugged in 2 and it didn't work, go back, check your work. Look back at your work. Any other questions on this here? Uh, 53 is not going to show up. Any questions on 52? Because 53 is the type where we ended up having to do this, getting the square root by itself twice. But that's not going to show up on the test. Any other questions on 54 or 55? So again, you're not going to find the inverse. Now, I want to look at 61, because 61 and 62, these here are going to be types where, for the bonus is going to be doing this here. And it's going to be asking us to show that the two functions are inverses. Now, to show that the two functions are inverses, we have to use our composite function. So our f of g of x and g of f of x. And if they are inverses, these here should be the same. Actually, specifically, they should both come out to be x. Because if the two functions are inverses, they'll come out to be x. Now, we're going to change that to plus 4. Because these two functions here are actually not inverses. If we switch it to plus 4 instead of minus 4, they will actually work out to be inverses, so that we can see how this works. So what we'll start out with is f of g of x. F of g of x. And just like with our previous functions when we talked about the composite, we're going to start off by plugging g of x in place of its function. So we'd have x minus 4 over 6. So I plugged in g of x. Now we're going to plug the x minus 4 over 6 into f of x, which would give us 6 times x minus 4 over 6 plus 4. And if we do the multiplication, well, it's going to work out that the 6 and 6 here would simplify to 1, telling us that we have x minus 4 plus 4. In the original problem, it was supposed to be minus 4. So minus 4 and minus 4, which would have given us x minus 8. But to kind of show that these are inverses, I switched it to plus 4, just for this example problem here. So in the answer key for this one here, for 61, it's saying no, that they're not inverses, because here we would have x minus 8, not just x, so it doesn't work. But on the bonus, it will work. You're going to have to show that f of g of x does get us all the way down to x. So any questions on this so far? We're good with this here? For the most part, I mean, that one change doesn't do a whole lot. I switched it so that we could see that these would work, or how it would work out if they were actual inverses. Well, now we're going to do the same thing going the other direction, g of f of x. Well, f of x is our edited version, 6x plus 4. So we'll plug 6x plus 4 in for f of x. Now we're going to plug our 6x plus 4 into g of x, which would give us 6x plus 4 minus 4 over 6. Well, in the numerator, I'll write it out, 6x plus 4 minus 4 over 6. Well, plus 4 minus 4 is 0, which would tell us that we have 6x over 6, which is x. Since both sides came out to x, it tells us that these are inverses. So for the bonus, most likely it's going to be asking you to determine if the two functions are inverses. So we have to show that f of g of x and g of f of x are the same, and more specifically that they both come out to x. If we do that, then we can say that the two functions are indeed inverses. Any other questions on this here? Any other questions on any of the problems, other problems on the review sheet? Yes. So f of g of x. So g of x is x squared plus 3 over 7. So the first thing for f of g of x, we're going to plug g of x in. Well, y'all can go on and go. If you want to see this, you can stick around and I will finish this out. Again, your test is tomorrow, and if you can get any of the missing assignments in by the end of the day tomorrow or Wednesday, I will take them. Because this is, again, one of the bonus. So at this point here, we would plug this into f of x, which would give us the square root of 7 times x squared plus 3 over 7 minus 3, all inside the square root. Now here, the 7 and 7 would cancel because we'll multiply the numerator by 7, which would give us 7 divided by 7, which just tells us that we have the square root of x squared plus 3 minus 3.
All I wanted to know is how to calculate that.
Yeah, and then we just get down to x. Then we would want to do it the other direction, which would work in a similar method, because we would get g of square root of 7x minus 3, which would tell us that we have the square root of 7x minus 3 squared plus 3 over 7. Well, the square root and square would cancel, giving us 7x minus 3 plus 3 over 7, which is 7x over 7, which is x. But that'd be it.
I was just
Calc